Hi there. Today I was just going to, because I was bored, I just decided to make a video explaining how to do integration by parts. So, as for an example of when you would use integration by parts, you have this upper expression here, right? The integral of 5x to the third log natural x dx, right? So, how do you do this? Well, first of all, the integration by parts is uv minus int v du is equal to int u dv. So what is u and what is dv? Or what is u and v in general, right? So there is a way to determine what you want u and you want v to be. So first of all, let's look at the Lie8 rule, which will help you determine what you want the u to be. Well, we have a log and we have an algebraic. So first up, number one is logs. So we want the u to be log natural x, right? And then that would mean that the dv equals 5x to the third dx. The reason that is our dv is because, of course, if we have this being our u, we need it to be specifically the dv, or else this is just going to be ud. And we need this to be the dv, so 5x to the third dx, right? So, now, the way you get v specifically, right? V is equal to the integral of this. So, we have over okay, over 4, so 5 over 4 x to the fourth. I'm sorry. I didn't plan on that, but that's just how that's gonna be, I guess. So you have that. So that is our integral for that. And now let's also go ahead and find du, because we of course need it for this. du equals 1 over x dx. That is because the derivative of this is 1 over x. And of course we have the dx, so that's not just, v times 1 over x and then with no no deriving thing, right? We need that in an integral, so we are going to include the dx there. So essentially our final expression is going to be, it's not final, but the one we have to simplify is going to be log natural x 5 times the log natural of x over 4 x to the fourth minus the integral 5 over 4 x to the fourth, okay, times 1 that over x dx. Now, what's x to the fourth over x? It's x to the third. So that would mean this automatically becomes x to the third. And it's, of course, very easy to find the integral of this, right? We do, yeah. That is right, isn't it? Can I pause this? No. Okay. We're just going to just hope for the best. So the integral of 5 over 4x to the third dx. So we do over 4, so 5 over 16 x to the fourth. That's what it's going to look like. So that minus 5 over 16 x to the fourth. But you can't forget the constant of integration, which is essentially just saying plus, some amount of constants, right? Plus constant. Just conglomerate every constant that could have been there for the derivative, and that's essentially what you have. So that would mean that this is our final. What is that? Get out of here. That would mean that this is our final line for the integral. You can place the constant at any constant, right? But yeah, you can place it at any constant. So you see how easy that is? That's pretty easy, right? Another type of problem would use like sine cosine, so trig, right? So 5x to the third sine x. Now, for this, you would use something called the tabular method. So essentially, first you would set up your set up your u, and you would set up your v. Now, the v is not sine x. That is the dv, as we just learned. So, if that is the dv, we need to find the v, so you need to integrate that. So, it's negative cos x. So, we have the first integral of that. You take the integration, step by step of that. But first, let's go and set up our algebraic derivatives. So, we got 5x to the third. That becomes 15x squared. That becomes 30x. That becomes 30, and that becomes 0. So, let's set it up. Go through all of them, right? And then it goes negative cos x, that becomes negative sine x. That becomes cos x, that becomes sine x. And that's all that matters, because anything times 0 is 0. Well, in this case. Anything times 0 is 0. So, that would mean that we need to set up our terms here. So, we got plus, minus, plus, minus. So, we got minus, plus, minus. So that's 1, 2, 3, 4. Yep. So then we do negative cos x 5x to the third minus negative sine x 15x squared plus cos x 30x minus sine x 30. The reason I set it up like that is because it's kind of weird doing multiplication by negatives, so I just went ahead and I set up the algebraic one to be second, so that I didn't have to, fiddle with the multiplications. So as you can see here, that is the area at every piece, but you also need to remember, of course, C, the constant of integration. See how simple this is, right? It's very easy to learn. It's only been like a few minutes here, and we've already covered most of the basics. Now, there's also a much more complex version that requires a special function. So let's go ahead and look at that, right? Sine x, and then let's get rid of the sine x. So let's make it easy on ourselves. E to the x log natural x. E to the x is, of course, not going to be our u. Log is going to be our u. So, u equals log natural x. Du equals 1 over x dx. Dv equals e to the x dv. Or dx, sorry, my fault. Then we have v equals e to the x, because the integral of e to the x is, of course, e to the x, because that's its derivative too. It just goes back and forth. So now let's set up our thing. We have log natural x times e to the x minus integral e to the x over x dx. Now, what do you do here? How do you solve that integral? Well, you use a special integral. So we have EIX. EIX is the exponential integral for x. So that is essentially negative x to infinity e to the negative t over t dt. So how does this become this whenever it's integrated? Well, let's solve this step by step. We have negative x, we got to plug that in. So that's essentially saying e to the x over negative x. And then we can essentially just remove this. I'll just remove that. That is what's going to be an integral, right? So we're essentially adding this special integral. So plus, right? Yeah, because it's subtracting. Yeah, it's a subtraction of, it's adding a subtraction, so it's going to be ultimately negative. So plus EIX plus C, right? Yes, because the negative times, yeah, that's what it's going to be. and it does know what an exponential integral is, so that's fine. We have that. That's going to be our final answer, I do believe. And I hope you enjoyed the video. Stuff like this, whenever you get to stuff like special integrals, that's where it starts getting a little bit more complex. But I hope I could have helped in any way that I can for calculus, because I really enjoy math, and I think that people, it gets a bad rap with how hard it supposedly is, whenever really it just requires, the right attitude going at it. This isn't, super complex, right? And, I get that, looking at it for the first time, it can seem really daunting to go at. So I just want to help, the people who want to go at it, but don't really know where to start. And I hope I did that. Thank you for watching, and bye.